So here's our initial setup for experiment 1. Initially we have everything laid out here, and you see this brown paper towel sitting here. The reason I have this is labeled, let me zoom in real quick. Right, you'll see it's labeled water, pyrophosphate, ethanol, ADH, NADH. Is that the reason we're doing this is because I am going to be using this micro pipette, so I don't want to cross-contaminate any of this stuff. So here, essentially when I'm done with the water, is that I'll be just placing this tip over here. Use another one for the pyrophosphate, one for the ethanol, one for the ADH. That way we're not wasting these tips here. And so essentially we'll just have each tip laying out so that we can go ahead and use that, because we're going to be doing 8 trials of this today. So these are going to be measured out in microliters. So I just kind of marked how much of microliters that I'm going to be doing with these micropipettes. So here, water is going to be 2,200 microliters. So we see the pyrophosphate, 500 microliters, 100 microliters of ethanol, 100 microliters of ADH, and then lastly, the last thing we're going to put into these is the 100 microliters of NAD. NAD is what's once we put this in, that activates the enzyme ADH. Right, so the last thing we're going to put in is the NAD. So I'm going to go ahead and set up all of these into our cuvettes here. They're not test tubes, these are cuvettes. This is what we're going to put in the spectrophotometer. They're a really high quality clear quartz crystal. So we're going to be using those. Even though they look like test tubes, we call them cuvettes here. So I'm going to go ahead and prepare those. I'll prepare one of them, and then I'll stop the video and prepare the rest of them. Alright, so let me go ahead and set the first one up for you, and then I'm going to pause the video. I'm going to do the rest of the cuvettes here, so we have a total of 8 for our 8 trials. So here, if you can see it here. Oh, this is awkward. There you go. I don't know if you can see it here. It might be a little blurred, but this is set to 1,000 microliters. So I'm going to have to use this a couple of times here. So I'm going to put this in the DI water. This is 1,000 microliters. I'm going to go ahead and put that in the test tube. I'm going to grab another 1,000 microliters, put that in the test tube, and I still need 200 microliters, so I'm going to use the smaller micropipette and extract 100 microliters and another 100 microliters. So that this gives me 2,200 microliters of water just in this. Now I need a 500 microliter sample. Oops, don't want to spill that water. I got a new tip here. The phosphate buffer. Let me put that into a small beaker here so I can grab that easier. So I need 500 milliliters. Let me adjust the micropipette to 500. So this will give me 500 microliters of pyrophosphate. I'm going to eject this here, place that down. I'm going to grab the smaller pipette. I'm going to grab 100 milliliters of ethanol. I'm going to grab 100 milliliters of ADH. Come on. And there we go. And the last thing, I'm not going to put it in now. I want to get all these samples prepped so that the last thing I'm going to enter before we put it into the spectrophotometer is we're going to put in 100 microliters of NADH. We're going to give it a shake, and then we're going to put in the spectrophotometer. So all of these samples are going to be prepped without the NADH. once we put the NADH in here, we'll have a total of 3,000 microliters in every single trial that we're doing. So let me stop the video. I'm going to prep all the rest of the samples. Okay, so we're going to blank this out with one of the solutions. So let me get this calibrated here. 340. I'm going to take one of the solutions without NADH, and we are going to calibrate this. So you'll see it flashing BLA, means that it's going to blank it out. So now our spectrophotometer is set. Alright, so what we're going to do here is once I put the solution in here, I'm going to put the NAD in here. It's going to activate the enzyme ADH. I'm going to put that in here. I'm going to close it up. When I close it, I want you guys to start your own stopwatch. I'm not going to give you the values here. You're going to collect your own values. Start a stopwatch as soon as you see this. As soon as you hear that close, start your stopwatch, and you're going to take a measurement here of the absorbance value at 15 seconds, at 30 seconds, 45 seconds, and 60 seconds. I'm going to record my own values here. When we go over the lab, we can compare our values. So initially that's what's going to happen here. So let me get this set up. Okay, and actually, you know what, why don't we start the timer? I'm going to put this in here. Yeah, so we're just going to go with that. So I'm going to do this very quickly here. I'm going to put this in here, shake it up before I put it in there, and as soon as you hear that click, just start your 15-second timer. NAD is in there. Start the timer. All right, so that'll be trial 1. I'm going to pause it, and we're going to go to trial 2. Here's the NADH. Remember, every 15 seconds, 30 seconds, 60 seconds. All right, trial number 3 coming up. All right, trial 4 coming up. All right. I'm not going to pause the video this time, I think we're going pretty quick here. So here we are. Trial number 5. Looks like we may have to... Well, no, let's keep going. Yep, I think this is going to be an outlier. I'm going to take these values, but I think this is going to be an outlier, and I don't think I'm going to use these. Yep, trial 5. Let's not, don't record anymore for trial 5. I'm just going to cross this out. Yep, so trial 5. Let's see here. Let me make sure that this is blanked out again. So trial number 5, just put an X through it. Calibrate it just to make sure. Alright. So this is trial number 6. A little bit high, but I think we're okay. All right, and then we'll take care of our last trial, trial number 8. Nope, see, nope, that'll be trial number 7. So we still have one more to go. Oh, this one seems pretty active. still think we're good. We got a lot of them that are around that area. I think this is the third one around that same frame. All right, now we'll get the last trial in. Yeah, right in range with most of the other ones. All right, so that'll take care of all the 8 trials for experiment 1 of lab 5. So I know that you can go to the video and get the exact point that I closed it and used a timer on the video to go 15 seconds and 30 seconds and 60 seconds, 45. But try and treat this as an experiment. Use your stopwatch, right? Use your stopwatch. As soon as you hear that click on the spectrophotometer, just set your timer. Set your timer, watch the absorbance value. When you hit 15 seconds, record the value. 30 seconds, record the value. Try not to use the actual video and get exactly the 15-second mark. You know, kind of treat this as if it was an actual experiment that you were doing it here live. So this concludes experiment 1, enough to get the calculations done. So I'm going to pause the video. I'm going to set this up for, or stop the video here. And then I'm going to set this up for experiment 2. Okay, so this is for experiment 2. So what we did here is we're going to run 8 trials again, but we are going to vary the substrate concentration. The substrate concentration in the last, or the substrate in the last experiment, and in this experiment, they're both ethanol. So what we've done here is we're going to change the concentration of ethanol to see if that will increase or decrease the rate of turnover on here. And we calculate that rate of turnover by the change in absorbance here. So again, we're going to record those values at 15 seconds, 30 seconds, 45, 60 seconds. So 15-second intervals are what we're going to record these values at. So I'm going to start with the first one. And again, I don't think I'm going to pause the video. I think I'm just going to continue one right after the other. So just make sure to reset your stopwatches. Pause the video, record your, and reset your stopwatches for the next one. I do have to blank this out, so let me blank the first one out here. And actually, I don't think I mixed these, so let me give them a quick mix. And then we'll go ahead and blank this out for experiment 2. Alright, so we'll put the first one in here. Oop. right, so these are blanked out. So this one here is the 0.10 molar ethanol concentration. Alright, let's go to the next one. Took one glove off to deal with my timer here. My values may be a little skewed for the first one, but it's okay. So the next one is where I added 0.3 molar ethanol. And don't worry if your values are not coming out the same for each one of these or similar, because remember, we are changing the concentrations here. We're changing those concentrations to see which concentration, so we can make a Lineweaver-Burke plot, Michaelis-Menten graph, so that we can look at this and see what happens with the change in concentration. All right, this is going to be the 0.45 molar. All right, coming up next, 0.6 molar. So we're definitely seeing some effect with a 0.6 molar. One 1.0 molar. This will be 3 molar. This will be, excuse me, this will be 4.5 molar. And our last one will be the 6 molar concentration of ethanol. All right. So that'll finish off all of our data for experiment 2. So there is some concentrations you need to calculate to get the final concentrations of the substrate. Using C1V1 equals C2V2 and some other calculations that we can go over when we have our our lab session over Zoom. So I'm going to prepare experiment 3 next.